So this week I'm very happy to introduce Dylan Gunn. Dylan is the director of the Engineering Physics Lab in our department. So maybe not everybody knows him because, as he says, he sort of hides in the basement some of the time. Um, uh, he gave a brief presentation of some work that him and other people in the lab have been doing on developing ideas for PPE in the coronavirus pandemic. So today he's going to give us a more extended version of that with an update of how much progress has been made in the last few months. So Dylan, it's all yours.
Thank you, Douglas, and thanks to everybody for joining. So I'll start with just a quick intro because I know many of you, but not as many as I'd like. So my name is Dylan Gunn, and I'm actually a graduate of engineering physics from 2006. And then I went to work in Andre Marziali's biophysics lab in the ChemPhys basement, and ended up starting a company there with Andre and four other graduates of EngPhys, actually. So a few graduate students and a few others who were working in the lab as engineers. And we started a company called Boreal Genomics. So I did that for about 8 years, ran the engineering team there. We were developing kind of a new method of manipulating and isolating DNA and tried all kinds of things, and eventually ended up developing one of the first what's called a liquid biopsy. So that's a cancer test looking for circulating tumor DNA in the bloodstream. So basically developing a blood test to test for cancer very early on. So trying to catch cancer in sort of stage one when you still have a good chance of being able to do something about it. So I did that for about 8 years. I did some consulting for a couple of years, and then John Nakane, who I'm sure many of you will remember, he left the project lab and is now the director of the integrated engineering program, and he's in materials engineering as well. So Andre asked me if I was interested in applying for the position of project lab director, and so I had to take that because it was just such a fun job. So we work on all kinds of projects. We do the kind of capstone projects with the EngPhys students, work with a lot of researchers on campus and a lot of companies around town. So if any of you have any crazy ideas or something you want to build, feel free to get in touch. We send an email out, once or twice a year, usually in the spring, to solicit projects, and always happy to chat with people, always looking for projects. So yeah, I'll be talking about some of the work we started in March, and some of it is still ongoing. And I'm representing the work of a huge number of people here. Most directly, my colleagues in the project lab, Medias Basescu, who also was at Boreal before he joined in the project lab. He's kind of head of software systems and machine learning in the project lab. He oversees all of our software machine learning projects. And Bernhard Zender, of course, who's our engineering technician. I'm sure many of you know Bernhard. He keeps a lot of the important equipment up and running in the department. And then there's a lot of other folks too who contributed to this both within UBC and external to UBC. So I'll try to call them out and give them credit along the way, but obviously I'll fall far short. Okay, so I'll get started here. This isn't a rehearsed presentation or anything. I'll have to move pretty quick. There's a lot of slides, but I'll just kind of step through. But feel free to call out if you have a question partway through. Feel free to interrupt. So just a couple of notes. This is kind of my perspective. Meaty may weigh in a bit here. This was a chaotic few months. There's lots of mistakes and gaps, and I'm sure other people who were involved from different angles may see things differently. Another kind of big point is, fortunately, a lot of the work that we did has not been needed, and I don't think it's often that you would say that about kind of projects that you worked on. But when Douglas asked if I wanted to give an update, I thought I think it would be interesting to reflect back on this and kind of reflect back from the perspective of asking the question, what would this have been like if the pandemic had been a little bit worse? A lot of the stuff we developed wasn't needed, but if it had really been needed, I think it would have been a really, really scary time. And I mean, it's scary enough already and has been impactful enough already. And finally, this is just a kind of a rough recap. So it's obviously not comprehensive. There's a lot of stuff that I won't be able to touch on. And I offer some very obvious conclusions at the end. So I'll start by talking about face shields. That was kind of the first thing we got involved in. And this really started on March 12th. So we have this big event every year in EngPhys, the project fair, where the students showcase their projects, and we really look forward to this. And unfortunately, we had to cancel it this year because of COVID, because it was right at that time where, at least for me, it's, I was hearing about this and it was becoming more and more real. And then there was that one day where it was, okay, we're, going to go into lockdown, everybody go home. And that was the day of our big event. So we had to cancel everything. And donate all of our catering to a charity in the downtown east side and everything, which was the one kind of positive of the whole thing. So I guess like everybody else, we all went into lockdown. All the streets were empty. Everybody's kind of hanging out at home. So I was, working from home, and this led to, inevitable social media browsing. And I came across a Facebook page that I saw a friend had liked that was called the YVR Makers for Emergency Response and Support. And I thought, what the heck, I'll check that out and see if there's anything we can do to help. Obviously, UBC has tons of tools, and EngPhys and the physics department. I thought, maybe there's something we can do. And I think I was probably the second person to join this group, which was kind of funny. And the first thing I saw people focusing on was 3D printing face shields. 3D printers were going to save the world, printing one face shield at a time. So they were printing these headbands and then getting these laser cut shields to plug in. And that seemed to be what everybody was focusing on. So I kind of jumped in and I started offering my kind of blunt opinions on 3D printing. Basically, 3D printing is a great technology, but I was really skeptical that it was ever going to be able to meet any kind of demand if this problem was really going to scale up the way it was looking like it might scale up. So I basically just said, hey, how can we help? I think there's much better ways to do this. And that kind of started a whole conversation. So, with this group, I started looking out across the internet, and in a few seconds found some two guys in the Czech Republic who had already developed a design of a face shield that didn't require 3D printers. So you could make these at a much higher volume. So Bernhard and I downloaded that. We tweaked it a little bit to simplify it a little bit and work on our lasers. Started building up kind of a big network of people who were getting involved. This fellow here with a PPE on was a rather outspoken ER doc who was in the news several times for kind of criticizing lots of issues with testing and PPE. Who is a local sales rep for a big laser company called Trotec. So this was us really kind of getting started with this project, just trying to find something where we could maybe contribute and thinking about scaling up, so getting away from 3D printers. And this guy, James, is really great. He actually drives around in a van with a laser in the back of the van to kind of give demos and stuff like that. And I think he's probably sold most of the laser cutters at UBC. So that's how we kind of got started. Another thing that happened really early on was, I don't know who actually introduced us, but somebody from the Conconi Family Foundation reached out and asked if they could help. And it was really like a 5-minute conversation. And they just said, what do you need to just get started? And, I was looking at securing materials and trying to put together, the biggest laser cutters in town and stuff like this. And I just said, look, if we had, $20,000, I could kick off a bunch of these projects and wouldn't need to think about anything. And within a couple of days, we had a check from them. So that was really interesting. If only every grant application was that simple. So we were kind of up and running with the laser thing, or with the laser cutting the face shields, and was really focused on kind of just getting the design done and stitching together production. And that was going really well. But then it started to take a bigger perspective, a bigger look at this. And a lot of, the groundwork was being done by folks in the making community. So this is, maker spaces and 3D printers and stuff like that. And, amazing that there's this capacity sort of distributed all over the place now. But I began to be worried because I think, that community really focuses on just making things. And there were a lot of people 3D printing things in their basements and trying to drop it off at hospitals and stuff like that. So we shifted and took more of a product development approach, especially Media and I, and this startup learned a lot about product development and all the steps you have to go through. So we started looking out a little further on where this was going to go if it really had to scale up. And this is all over the course of kind of a few days in mid-March. So started reaching out and actually trying to figure out, like, how are we actually going to, give things to the PHSA or sell things to the PHSA or hospitals if we need to get to the point where we can do, thousands and thousands per day. And had a lot of conversations with a lot of different people. This is a redacted Facebook message from somebody I was communicating with who was like a nurse leader in a local hospital. And just really kind of made it real. This is, in the early days when things were ramping up and everybody was quite concerned. I think there was a lot of confusion about how deadly the virus was and how much protection was required. And they were still putting together protocols in hospitals and working it out. And so this person was just talking about, from a nursing perspective, they didn't have the freedom to just secure their own PPE. And a lot of them were getting in trouble for trying to use face shields, and hearing from lots of hospitals where they had one or maybe two face shields, and they were reusing them so many times that they'd already become cloudy from being wiped down. And they're having to, practice intubating patients where they're getting covered with sputum and things like that. So a lot of people were really quite freaked out about this kind of thing. So we started really looking into how do we actually do this properly, and how do we sort out this whole supply chain and the approvals and all that kind of stuff. And I'm hoping there's a few EngPhys students who are joining here, a few students from the project lab. I sent them a separate invite. In the project lab with all of our projects, we're always harping on the students to just get on the phone and call people when they need information. Obviously, it's important to kind of do your background research and Google and things like that, but sometimes it's just sufficient to get on the phone and try to get answers. So we call these phone safaris. It's not unheard of that we'll be in a meeting with students and we'll just pull out our phones and start calling people on speaker right there to try to get answers. So we encourage our students to do this. So we did a lot of phone safaris. I did a lot of phone safaris. This is actually, I went through my phone bill from kind of March, April, May, and added up. Blue is the number of calls per week, and orange is the number of hours per week spent on the phone. So I massively increased the amount of phone calling I was doing. I think here it was like 30 hours spent on the phone in 1 week. And kind of hilariously, this mapped on, this is a stretched out plot of new cases, of new COVID cases in BC. So my phone calling mapped pretty well onto the COVID incidents, which I thought was kind of funny. But was just calling tons of people, like trying to figure this out. And at the center of all this is the PHSA, the Public Health Services Authority of BC, and they're the kind of entity that oversees all of the hospitals and all kinds of other sort of care-related organizations. And really, really complex. Obviously, it's a huge institution, multi-billion-dollar budget, 18,000 employees. You can see the scope of everything they're responsible for. And just like an enormous problem they were facing. And they're obviously used to being a health authority that's ordering, billions of dollars of stuff out of a catalog. And then all of a sudden in March, the catalog is empty for the most critical items. And all of a sudden they have to become like a manufacturing company and overseeing this huge supply chain, some of which is going to be sourced locally, some of which is being sourced from new factories that are popping up. Obviously, China was way ahead of us in the curve, and a lot of new capacity came online in China, probably in like December, January, February. A lot of those people were now trying to sell stuff to British Columbia. Obviously, the best stuff probably wasn't getting out of the country. So there was just a lot of chaos going on. And lots of stuff appearing in the news. We were hearing about this within the PHSA, just trying to compete in the marketplace, compete against big federal agencies in the States to procure and stuff. So it was really, really confusing. And I was calling around trying to figure out, look, we're going to be able to make thousands of these things per day. How do we actually get them to you as opposed to just having people come by my house and pull them out of the garage? And so I was doing a lot of phone safaris, and I was talking to a woman who was trying to be, very friendly and helpful, but I think didn't really understand what I was trying to put together. And finally she said, okay, hang on. There was a woman here a few days ago. She's like a consultant. She's trying to, figure this stuff out from the inside. I'll put you in touch with her. And I ended up getting in touch with this lady, Monica Ferragrino, who's a supply chain professional. I had no idea what a supply chain professional was before this, but I can now attest to their value. So I ended up tracking her down and having a phone call with her late one night when I was in the project lab kind of prototyping on the laser cutter. I Eventually started calling her the CEO Laserbeam for reasons I'll explain later. But had a good conversation with her. And I was talking to her and trying to explain how difficult it was for, I was stitching together all this supply, and we were figuring all that out. But we had no idea how to actually get this into a hospital. And then she said something that I thought was kind of strange. She said, "Oh, I'm really glad you're reaching out to me. You're from UBC. I've been trying to get in touch with you because somebody from UBC, sent me an email or submitted a form saying that, they have a ton of 3D printers and they can make PPE." And so in her mind, she's thinking, great, amazing. This is the biggest academic institution. They must have tons of these. This could solve our problem. And so I asked her about this and who this person was. And it turned out that she had received an inquiry from one of the student teams who had reached out, like many people with 3D printers, saying, "Hey, we're from UBC and we have 3D printers. We can make PPE." But this is in the Hennings high bay basement. And they had a few printers, I think most of which were non-functional. And this really freaked me out, that this was a woman who was consulting directly to the executive team of the PHSA and was responsible for trying to domestically source PPE and also stitching together new kind of global supply chains. And she was trying to get back in touch with this person to produce PPE. So that just really indicated to me like how fundamentally broken this was. So this is what I felt like after having that conversation, was just really kind of freaked out and frustrated about how broken this was. So anyways, we kind of kept working on that, and the production was coming together. But then we switched to focusing on N95s because it looked like the face shield thing was kind of coming together. So all the while, when this was kind of ramping up, it was clear that the N95s were going to be the biggest issue. Obviously, it's an airborne pathogen. Respiratory protection is the most important thing. And we'd stayed away from this initially because N95s are quite complex. It's not the kind of thing that you can make in your basement. It requires really specialized materials, and the fit is really important. Durability, resistance to moisture, all that kind of stuff is really quite critical. But obviously there was lots of terrible stuff happening. This is from Ohio, but we heard from lots of nurses and doctors that similar rationing was taking place in BC. So people were being given a single mask in a paper bag and being asked to use that for several days, which just goes against every kind of guideline. But there was a couple of weeks where pretty much every day the CDC and the FDA were publishing revised guidelines, revising their guidelines around PPE usage and especially N95 usage. And it was just really kind of scary to watch because everybody's trying to interpret all this and, all these sort of, fuzzy language like can be reused by the same worker as long as it remains functional. And it's like, well, what does that mean? I mean, how do you assess whether it's still functional? So we were watching this kind of unfold in real time, which was really scary. And then late one night, kind of as I was falling asleep, I was reading the news and saw this article. And this is a UV sterilization tool, I guess you would call it. It's like a little cart with some UV bulbs on it. And you would wheel these into hospital rooms to help kind of do like broad suppression of pathogens, say after you've cleaned up an OR or something like that. And in the foreground here is like a clothesline with clothes pegs on it. And they were hanging N95s in a room, wheeling this cart in and turning it on and hoping that was going to decontaminate the N95. So I saw this and read this article and thought, okay, you know what, if this works, this is actually something that we could probably engineer pretty quickly and turn into a scalable solution. So we put together a team. I'm not sure how we met these folks. I mean, obviously, so there's Bernhard Zender from the project lab and Meaty and myself. But we had kind of co-created and been sucked into a big Slack channel that at this point was probably around 100 people from all over BC. And it was basically anybody I ran into who was working on this. I said, okay, join the Slack channel and let's all get on the same page. And we had all these groups set up and things. And it was my first time ever really using Slack in any serious way. And it was really cool to watch it kind of self-organize and become really productive. But we met this guy, Jordan Belenko, who's a recent graduate and consulting engineer. And then Brian Gibney, who's a radiologist at VGH. And then there was this UBC startup, Accuva, which specializes in UV-based water purification for things like RVs and boats and stuff like that. So we sort of pulled all these guys together and said, okay, look, can we do this, and can we do it in a hurry? And the starting point there was Brian had actually just returned from the UK, and so he was quarantined for 14 days, and having a super sharp radiologist who's stuck in his apartment for 14 days and loves doing literature reviews is a very useful thing to have. So he just looked at every single publication he could find, summarized kind of all these critical parameters around testing and what type of UV and the dose and the performance and all this kind of stuff. Because there was a bunch of literature from previous pandemics. This has been an ongoing problem, shortages of PPE that pop up. So there was some literature to go on. Accuva did some modeling for us, calculating the irradiance and if we put the bulbs here and there. So sort of, simple stuff, but helping us just figure out the geometry so that we could try to get consistent illumination and irradiance. And they jumped on this right away, which was super helpful. So they did some kind of basic modeling for us. And then we jumped in and did what we do in the project lab, which is, try to throw together a very simple design. This is one of the guys testing a lamp and a radiance with a N95 tied to a chair in his apartment. Bernhard got straight to work and does this great video, which shows, I think, one of Bernhard's amazing skills is he can just figure out how to build something with the bare minimum. So this is a box where these little tabs you twist and it all locks together. So this is a video of him assembling one of these boxes in a couple of minutes. And it's interesting, it's probably too blurry to see here, but this has 13,000 views, which I thought was really interesting. It was only posted a few months ago, but it shows kind of the level of interest in this sort of stuff. So Bernhard always wins for kind of the simplest and most robust design. He also wins for the most ingenious. He came up with this idea here. Really critical for this kind of thing is you need to really control the dose, and you need to make sure that all faces of the mask are exposed and things like that. But germicidal UV is also really, really dangerous at those kinds of power levels. It will really damage your eyes very, very quickly. So you have to design this in such a way that it's inherently very safe. And we didn't have time to do this with microcontrollers and interlocks and all of that kind of stuff. So Bernhard came up with this idea. It's sort of hard to explain, but it's like a rotating thing that you pull in and out, and you can't expose yourself when it's rotated, and you can't pull it out when it's locked in, and things like that. So he actually turned this into a functional prototype. But I was kind of a jerk and very insistent that we needed something that was going to be dead simple to fabricate and scalable, something that we could, turn into a big cabinet or a small cabinet, because we were trying to understand this problem and talking to folks in the health authorities. And there was just a lot of confusion about, is this going to be on the ward? Is it going to be in some centralized facility? Like, just tons of questions, and nobody really had clear answers. So we came up with this design. I won't go into the details, but it's very simple. It's just a drawer with, bulbs. You could make this as high as you want, and the mask slung up in between. But we designed this in such a way that there's no way to get exposed to the UV. And you want to leave the bulbs on 24/7, because the more you turn them on and off, the more that shortens their lifespan. So we threw together this design really, really quickly. We threw together a very quick proposal. The EdgePhys students will probably recognize all these headings here. This was a good practice in what we preach in the project lab. So we wrote a quick proposal. What would it take for us to get this to a point where we could do kind of tens of thousands of these per day? And then we also, while we were doing the engineering, Jordan, the fellow I mentioned a few minutes ago, was really, shopping around and doing tons of phone safaris and trying to figure out, who is it that's going to approve something like this, who would fund it, all that kind of stuff. And this guy is the unequaled master of the phone safari, as far as I can tell. He just, I would talk to him a couple of times a day, and he would just go all across the planet. I don't know how he got to talking to so many people. But this was like pretty typical of what would happen. So this is an email he sent me. He's talking about how he was talking with his old boss, a company that, he thought might be able to help. And there was this sort of closed loop where, can you guys do the material testing? But what had happened is somebody else, one of the regional directors of infection control, had been put in touch with this person. this person had referred her to Jordan, and Jordan had already been put in touch with her. Jordan had already found her about doing all the testing and trying to approve this. So we just ended up at the center of like a lot of circular loops, I think, because we were making more phone calls and collecting more people and ideas than a lot of other people. So that was kind of funny. Around this time, we became aware of a really interesting resource that was being put together. This is called the Open Source COVID-19 Medical Supply Guide. This was, it's basically a collection of Google Docs. I won't click through in this meeting, but this was really inspiring to see and really inspiring to watch it come together. This is hundreds and hundreds of Google documents, all hyperlinked together into a very well organized tree structure. And you can click through to everything from the science of COVID to drugs to PPE to manufacturing to reuse to supply to basic materials to what types of 3D printing will withstand what types of decontamination, like absolutely everything. And buried in here was a page on N95 reuse and decontamination. So we started contributing to this, like our literature reviews went into here, things like that. But this led to a problem pretty quickly, which is, when you have a resource like that, all of a sudden everybody everywhere in the world has the same idea at exactly the same time. So we were working on this UV project, and then all of a sudden, all of the UV bulbs and ballasts started disappearing from all over the world. And that's not dissimilar to a problem maybe everybody else here experienced in a more personal way. But it really did become a major issue. We had this design put together, and we were talking to all these companies, most in the States, and they just said, like, look, everything is flying off the shelves. We're not going to have, anything in a couple of days. So we had this proposal. Jordan had pulled together all of the directors of infection control for the regional health authorities, so Fraser Health, Vancouver Island Health, Providence Healthcare, things like that. And on a Saturday afternoon in April, we had a meeting with all of them and said, hey, look, here's our proposal. We think we can do this in a short amount of time. We could have a bunch of these up and running within, a month probably. And they said, okay, we're going to bring in the kind of our counterpart from the Ministry of Health at the provincial level. So we did that Sunday meeting. We had a meeting with them and this provincial director. And we said, look, if we want to do this, we need like $150,000 to $200,000 tomorrow morning to secure all of the bulbs and ballasts. And he just said, okay, what do you need to do the whole thing? We said, I don't know, we think 300 or 400K. He said, okay, let's call it 400. We have a meeting every night at 10 p.m., an emergency meeting in the Ministry of Health, and I'll get approval and, call you in the morning. So this looked like it was going to be a go very, very quickly. And again, if only every grant application were this simple. So we had that, but then on Monday morning, we actually got a call from one of the directors of infection control, and there was a paper that came out of Yale. So that OSCMS, there was a lot of research coming out in real time, and Yale published a study saying that the best way to decontaminate N95s was actually to use vaporized hydrogen peroxide. So that changed things immediately. They said, okay, let's put a hold on this project. Don't buy all the bulbs. And this scaled up in a major way. This is from a little bit later on, but in the US, Battelle, a big defense contractor, got almost $500 million to build 60 of these systems, which were vaporized hydrogen peroxide in shipping containers. So we put a pause on that, but it was a little bit frustrating because the PHSA and the folks we were talking to really only were talking about the hospitals, and their vaporized hydrogen peroxide equipment was only in the hospitals for sterilizing, surgical equipment. And we were asking them, well, what about the ambulance services? What about care homes and firefighters and the downtown east side and all of these other people? And it was just kind of we don't know. That's not really our purview. So that was really kind of frustrating, but kind of indicative of the kind of compartmentalization of these authorities. So we left that project there for the most part. There was some interest in decontaminating stethoscopes and all that kind of stuff, but we just said, you can get that sort of stuff from Amazon. So we left that. Back to face shields really quickly, because that was still in progress. So at some point I had the idea to kind of go for the Hail Mary and see if we could solve this problem, in one spot. And I thought, well, who in the world can produce large amounts of, clear plastic, some things in a hurry. And I thought, well, there's bottling plants all over the place. And so I actually just called like a 1-800-Coca-Cola number, ended up speaking to a customer service representative in Atlanta, Georgia. I explained to her what I was hoping to talk to somebody who actually worked in manufacturing for Coca-Cola. Went on a phone safari all the way from Atlanta to other parts of the States, ended up in Montreal, went all the way up in marketing to somebody very senior in Coke marketing, and then ended up in Canada, went down into manufacturing. And within 4 hours, I got a phone call from the guy who oversees all of the Coca-Cola bottling plants in Canada. And he said they can make, I think he said it was 40,000 bottles of Coke per minute. So I thought, okay, this could be really amazing. But he said it's so automated that it takes them 6 months to even make a tiny change to this automated manufacturing process. So it was worth a shot, but it did indicate the kind of power of a good phone safari if you have kind of a clear message and a clear need and a lot of people who want to help. So I found kind of the next best thing. The laser van guy, James, introduced me to one of his customers, this fellow Colin Chu, who runs a company called Packrite Manufacturing out in the Valley. And they make all the clamshell packaging for the berries that you buy. And he was starting to look at this problem because he does tons of plastic stuff. So James linked the two of us up, and I said, hey, I've been working on this. I've got a design that I think will scale. We've talked to lots of doctors. I'm getting some headway on the regulatory stuff, things like that. So he and I linked up, and he was sorting out all the manufacturing. So this wasn't at this point, but he did rent out a whole bunch of additional space. He hired a bunch of staff. I think he had close to 20 people assembling these things. And he was getting to the point where he was making thousands of units per day. And just an amazing guy, was doing this totally at cost, working 8 days a week, not interested in making a profit at all, just a really phenomenal guy to work with, and just wanted to do whatever he could to help. The problem, though, was that we just weren't making any progress with the PHSA, and tons of doctors were reaching out to us. We were selling stuff to individual hospitals. They were bypassing all of their own supply chain stuff, bypassing the PHSA. And it was super confusing, and the standards they were using were all out of date. The standards they had for face shields were for like grinding and projectiles, and they had to be made out of polycarbonate, and it was just like completely breaking down. And this is connecting with Health Canada and trying to give them feedback on their guidelines and things like that. So we did, the only thing we could. I went on an actual safari and got in my girlfriend's pickup truck and drove out to Langley to the warehouse where they bring everything in from China. They store it in the warehouse and then they send it out around the province, because they told me that's where they're actually looking at all this stuff. And we'd sent many, many samples to this warehouse and had 0 responses in probably a month and a half. Like, it just disappeared into a black hole. So I actually just banged on the door and got in and found the woman who was trying to do all these assessments. And she showed me the one that she said they liked, because, a few people who had tried it said it was the most comfortable, but it was very clearly cut out of plastic sheet with scissors. There was like an underwear band that was stapled on, like literally with just staples. And some guy had said he could, make as many of those as were needed, but it was clear that this was just, cut out with scissors. So unfortunately, the person who was doing this, was not a supply chain person, didn't know anything about manufacturing. You wouldn't expect them to, because normally they're just, ordering stuff from catalogs. So, I talked to her for a few minutes. I drove up the street. I grabbed Colin. We came back. We showed her the manufacturing facility that he had 5 minutes away on the other side of the highway. And Colin was already making thousands per day at this point. So, I felt like we were making progress there. They said, okay, great. We'll get all the approvals. This looks fine. So I left that. And then another project popped up. I'll be really quick on this one. But this was pretty interesting. This was run by a guy named Mike Rooney and a bunch of engineers that he works with. He's in UBC chemistry in the Berlin-Get lab. And this news article came up from Taiwan, and it was this fellow in Taiwan who just made a little acrylic box to put over patients when they're doing the intubation, so to put somebody on a ventilator. And a lot of people picked up on this. And so we actually heard about it from doctors in our network who said, look, can you build us these? We need these. And they were doing these simulations. They do it with like a fluorescent dye showing that when you intubate people, you just get covered in sputum and saliva. And it's bad enough that when you're taking off like all these gowns and things, there's so much of it that, you know, you still end up covered in it and it gets all over the hospital. And so they wanted something to just be like a first barrier. So Mike and his team did a phenomenal job iterating on this very, very quickly. We got a small grant from Genome BC, and they built a website and had all this information. They were putting up their videos and protocols on how to use it. And this got picked up by a bunch of groups around the world, which is great. So that was an example of just, you know, things scaling up very, very quickly. I had very little involvement in this, and Mike just ran with it. So then back to the N95s. So the UV thing hadn't worked out, but it was still pretty clear that there was a massive need for the N95s. Even with the hydrogen peroxide, you can only reuse a mask a few times, and there was a lot of controversy about, you know, just how many times you could reuse it before it would break down, because there's no way to look at it and say, hey, it's still good. You're just kind of assuming that it's going to keep working. So then something came up in the news, huge shortage of N95s, but people started talking about these KN95s. And in the States, there were all these stories about wealthy individuals donating KN95s. And KN95s are the Chinese standard. So they have the same filtration performance, or they're supposed to, but they don't fit. They don't form a tight seal. So there's all this news about how this is going to save the day. But then a few weeks later, it was pretty clear that this was not the case. The people in charge of respiratory protection, you know, very quickly showed that, sure, the material is fine, but it doesn't form a seal on the face. So it's actually not doing anything effective. And then this was happening in British Columbia as well. So we were contacted by Monica again. She sent out an email saying somebody's donated, or they've managed to secure millions of these KN95s, but we need to make them fit. And they'd failed every single test. But this was really their plan for the next several months for respiratory protection. So we pulled together a team. We were in touch with a lot of these folks already. So just very quickly, an industrial designer that Needy and I work with, David, who's with a local UBC startup. Maddie and Karen are in the School of Population and Public Health. Steve Rojak is a MEC prof. Daryl Murphy is with a local prosthetics company. They've been really helpful on a number of our project lab projects. And then Barry Coleman is with a local injection molder. So I'll try to go quickly here. I'll skip through this. But basically, this was the project. At some point in trying to solve this, we initially thought we could build a frame that would go over the mask. This turned out to be very, very difficult. It's really hard to accommodate different people's face shapes. But at some point, one of the folks in the supply chain said that they'd purchased about 12,000 of these respirators, so probably $500,000 worth of these respirators. But the problem is that they couldn't get a hold of the cartridges. So they had all of these, but nothing to plug into them. So we said, well, if you've got 12,000 of these, we should be able to make a cartridge where we can just put this KN95 over the top to get equivalent performance. So we mocked this up very, very quickly, took an existing 3M cartridge, cut it open, and just put one of these KN95s on top. And it turned out it worked fine. It scored above the maximum readings for filtration performance on all the tests. So this is what we focused on for the past several months. So we did lots of prototyping and design, and it was, you know, really important to have that right team there to do all the design. Went through several iterations. And these are the tests. So like I said, you're looking for the ratio of particles on the outside to particles on the inside of the mask, and 200 is where the machine maxes out. And so on every test we did, this was at least 200. We've done a bunch of testing on wear and things like that. So, you know, just checking that these are going to be okay when you're using them for, you know, many, many days or months at a time. So we spent kind of probably a month really intensively doing the initial design and prototyping. And honestly, we're 99% of the way there probably a few months ago. And then just the past few months have just been about tweaking the mold tool and things like that. And it's less urgent now because they have managed to get some supply online. So we've backed off a little bit, but we're planning to wrap up this project in the next month roughly. Just this week, we finished all of the injection mold revisions. So, testing and tweaking the injection mold. We just secured the purchase order from PHSA for 200 sets of parts. We'll use those parts to do all of the testing against the NIOSH N95 standards. So Vancouver General Health has built a lab. They managed to get a hold of one of these machines that can actually do the N95 NIOSH testing. It's the only machine in Western Canada, and I think the only other machines in Canada are at the NRC in Ottawa. I think there's really only 2 facilities now in Canada that can test this equipment. So we're going to do that. We need to apply for a WorkSafe BC variance order, and this is what would allow healthcare workers to actually use this in the event it's needed. And then we're going to send a bunch of kits, so packs of 10 of these, to all of the directors of infection control and respiratory protection and the regional health authorities. And then they want to place this on standby in case it is needed. So with 12,000 of these respirators, that would be enough actually to supply all of the demand. The peak demand in the province, they were going through about 12 to 15,000 N95s per day. So if needed, this could potentially get BC to a point where it could survive with just KN95s, which are much, much easier to get a hold of. So that's kind of all the projects in a hurry. I'll wrap up really quick here. So some conclusions, if we want to call it that. So I think some things we learned, one big one is not trying to resolve the problem with your own design that is better, cheaper, faster, et cetera. And I'm saying this, we did a bunch of our own designs, but I think there were a lot of things we saw where people said, okay, I'm going to make a new face shield, I'm going to make a new ventilator, I'm going to make a new, and with the OSCMS, we saw very clearly with SARS and MERS and all these other pandemics, there were tons of validated designs. There's been billion-dollar projects to make low-cost ventilators and things like that. So there was just a lot of effort going into kind of, I think, redoing things as opposed to looking at what's already been done and saying, hey, we have a design, let's just focus on getting the supply chain sorted out and manufacturing these. Another one is doing things individually. A lot of people were kind of hunkering down and just focusing on, okay, I'm going to do this and I'm going to reach out, I'm going to call the hospital, I'm going to call the regulators. And this became a massive problem because there was so much noise. Everybody being overwhelmed by just all of these messages going back and forth. So a lot of the phone calls I was making, I was trying to pull everybody together, trying to pull everybody into one Slack channel, trying to pull everybody into teams to reach out individually to kind of cut down on the noise. And that did happen over time, but it was very, very confusing and I think really wasteful at the start. Another one is giving equal weight to every effort. And this comes from a phone call I had with an aide to Minister Baines. He's the federal minister of, it's not science and technology, it's innovation and something now. But their ministry was tasked with, trying to get kind of Canadian industry to deal with this problem. And they had a big website where people could submit, offers and all this kind of stuff. And this aide was, talking very cheerily about how they had a list of 3,500 people they needed to get back to. And they were just calling one by one. And they were talking about all the wonderful mom and pop shops they'd talked to in every small town that had called them and said that they could, make 5 face shields a day and stuff. And I was like, well, why don't you guys just look at all the biggest companies on the list and start with the top 5 and forget everybody else? And I just ran into that so many times. There was no idea of priority or scale, which was really, really kind of frustrating. And another one, this came up a lot. There was a lot of projects going forward because, a doctor or a single nurse or a medical person had said like, hey, this is great, let's do this. And we did that at the start too, but, I think it's important to realize that there are people that, we don't interact with or we're not regularly, aware of them, but there are people inside these organizations who are specifically tasked with supply chain and regulatory and procurement and things like that. So I think there were a lot of projects going forward because, a doctor or a nurse, we all know doctors and nurses had said, hey, this looks good, let's do it. But, they're not aware of all the regulatory issues and how it's going to be tested and all that kind of stuff. So that was kind of another big takeaway. So I'll stop there. And I don't want to take up any more time, but that's kind of a quick version of the whole story. I'm trying to get in 45 minutes here. I think I'll stop and just say any questions about all this stuff. Thank you.